Hello, hi everybody. I am Ram Mohan. I am working as head of electronics department. Presently, I am placed at Government Polytechnic, Mahbub Nagar. The subject we are looking here is the basic electrical and electronics engineering. The topic of our discussion is inductors and transformers. The subtopic of our session is the derivation of the equation for EMF of a transformer. So let us see the objective for this session. So the objective is this. On the completion of this session, you would be able to derive an EMF equation of a transformer. So that means you are going to derive an expression for calculating the value of EMF induced in the transformer. Now let us recap what we have discussed so far. So on which principle does a transformer work? It is electromagnetic induction. Yes. Give an expression for the induced EMF in a coil of the n number of turns. To remember that E equal to something, yes. So it is E is equal to minus n d5 by dt, where d5 by dt is the rate of change of flux. It is the rate of change of flux in Weber per second, and n is the number of turns or in the coil, and E is the EMF for the EMF that is induced in the coil. So here is the principle of working of the transformer what we have discussed in the previous session. So the primary, you can see there are more number of turns, and the secondary there are few less number of turns, or here 4, let us say. And we have discussed that rate of change of flux is the main cause of working. It is the main principle. So in the primary of the coil, you are going to apply an alternating current which is changing its phase every 180 degrees. So AC is 50 Hz cycle. So 180 degrees phase shift. So here you can see the direction of the current flow is also changing in the animation over there. So the flux linkages or the changes due to the current change in the primary, they are linked to the flux change to the secondary. As you can see, there is an arrow showing over there, and the direction is also changing. And this change of flux in the magnetic circuit is going to induce an EMF in the secondary of the coil. So that is how the transformer is working. So this is also what we have learned in the previous session. We have also learned that when the current is flowing in the primary of the coil, that is resulting in flux due to it to flow in the ferrite core or the iron core. So in the, that is the magnetic circuit. That flux, when it is flowing through the circuit, it is going to cut the lines of flux of the secondary coil. So this secondary, in the secondary there will be voltage that will be induced due to this. And even here it is properly mentioned that the output is coming at the bottom of the wire of the secondary winding. So that is how actually there is going to be 180 degrees phase shift due to the transformer induced voltage. So that is how it is working. So here we have seen the working of the transformer. So because of changing flux at the primary, there is changing in the it's a varying flux that is traveling in the magnetic circuit of the transformer, and this is actually linked with the secondary of the transformer. So the EMF is induced in the secondary of the transformer. And we have seen a simple, we have seen two methods of magnetic flux linkages. The simplest form is this one, wherein actually the circuit is simple. You have one only magnetic flux linkages circuit. There is primary and secondary are only 2 arms. And practically the most efficient one is the one which is there on the bottom, that is more efficient, wherein the So this is the best method of implementation of the transformer principle for step up or step down. So we also remember that the working of the transformer is like this. Normally the step down transformer is used. As you can see, the primary there are more number of turns and secondary there are less number of turns. So as you can see in this picture, as the number of turns are increasing in the secondary winding of the transformer, the output voltage is also increasing. So when the output is more than the primary input, which is called as a step up transformer, and when the output is less than the primary, the output voltage, then it is a step down transformer. So it is given by turns ratio 1 is to n or n is to 1 like that. So you have the ratio turns ratio of the for the working of the transformer. Now further we'll see the derivation of the equation for the EMF used in a transformer. Now let us proceed for the derivation of the equation for the EMF of the transformer. Let phi is the flux produced in the core into the primary winding, because that is the source of energy where we are primary the primary. We should start with the primary. Then phi m is the maximum flux in the core under any situation, because we are talking of a variable flux or a variable voltage. And phi m, that is the maximum flux in the core, will be equal to Pm into A. A is the cross section area, and N is the number of primary turns, and M2 is the number of turns in the secondary of the transformer coil, and then F is the frequency of the supply. Normally in our country it is 50 Hz as we know, and U is the RMS value of the primary induced EMF, and similarly E2 is the RMS value of the secondary induced EMF. So the derivation of the equation for the transformer. Now this is the waveform we are going to apply. So here you can see that at quarter cycle, that is at pi by 2, the phi will be maximum, which is denoted as phi m. Flux increases from 0 to the maximum value as we go on increasing the value of the voltage or the current that we are applying at the primary windings. Now phi m is the maximum value at which is occurring at 1/4 of the cycle, that is 1/4 f seconds. Then the maximum flux occurs at 1/4 f seconds. Now we know from the Faraday's laws of electromagnetic that the induction, the EMF induced is directly proportional to the rate of change of flux. So let us further proceed for the. So the average rate of change of flux is d phi by dt, that is equal to maximum flux divided by time of occurrence, and that is given by phi m we have taken there, and time is 1/4 of f, so that will give equivalent to 4f into phi m. Now average EMF per turn is equal to 4fm, and if flux is sinusoidal, then RMS value of the induced EMF is equal to RMS value of the EMF divided by the number of turns. So now we are actually trying to relate it for the further derivations. So that is equal to average value into form factor, and the form factor is 1.1 for transformers here, and so it is 4f into phi m, which is maximum flux, into 1.11. So that will give an equation of 4.44 transformer V1 is equal to E1 and V2 is equal to E2. So that is how we have to substitute this value for ideal things. Normally we take it as an ideal situation. So now let us conclude further. So for the derivation check, what is it? So we have the equations as shown for primary and for secondary. So it is E1 equal to 4.44 into M1 F into 5M and E2 equal to 4.44 into M2 into BMA. So this is what we have for both expressions. Now let us see the summary of what we have discussed. So we have discussed and derived an expression